Let's see. Leetcode. Okay, let me just get this problem ready here. Oh, sorry about that. All right, let's see what this problem is. Find the encrypted string. You're given a string S and an integer K. Encrypt the string using the following algorithm. For each character C in S, replace C with the kth character after C in the string in a cyclic manner. All right. So for each character, we're going to replace that current character with the kth character. So K is 3. So 1, 2, 3. Ah, okay. Okay, I see what's going on here. So this is the current character, D. We want to replace D with the kth character, so the third character. 1, 2, 3. So we replace D with T. Then we go to A, and we want to replace it in a cyclic manner. So R, T, and then we circle back around to D. So we replace A with D. Then we go to R, we replace R with A. And then we go to T, and we replace T with 1, 2, 3, R. All right. That makes sense. Let me just get this set up here. Get encrypted string. We have 2 examples. So I'm just going to test it in my code editor so I don't submit any incorrect answers. Does anyone have any thoughts on this problem or thoughts on a solution? All right, so the second example,
I have
AAA.
an idea.
Yes, sir.
So we can double the string. So the first example, it says dart, right? DART. So we can make it DART, and then calculate loop uh loop loop over the first 4 characters so that we get the third character. Can we do that?
So let me ask you this. Yeah, we could do that, but if we double it, there might be a problem, right? Because if K could be anywhere from 1 to 10,000, the power 10 to the
Mm.
power of 4, is it possible that we have a string of length 3 but a K of 1,000? Because in that case, doubling it
Okay.
won't work. But let's see. Let's see.
Okay. I think
Here
we
is
can take the remainder of 1000, like 1000 mod length of the string, and whatever's the remainder we can loop it over that many times.
so you're saying extend the string
Yeah.
based on K.
Yeah.
So you
Or
take the length of the string and mod K, you said?
mm-hmm.
Hmm. Let's see. So let's just do an example here. So let's say the string is 10 and K. String equals 10. K equals 1,000. What are we going to get when we 10 mod 1,000? And then what if in this we're going to get 1, right? Are we going to get 990 here?
No,
What are you going to get? 0, right?
we get 10.
10? Oh, yeah, yeah, yeah. Okay, okay. So then you would And then, all right. So then, what would you do here once you have the answer to mod?
We repeat, we loop over that many times, so it become so let's take a 10, uh, take a string of length 10 and we double it. So this time we check the 10th, 10th character from whatever character we are in, so we loop over it 10 times. It's basically, it's like how many times we loop over the string. That's the result.
Mm.
I don't know if it works because I'm still in the like pseudocode stage. I haven't like coded it up.
Yeah, no, I'm trying to think through. I'm trying to here. Let me. I'm gonna go ahead and create the live share link in case anyone wants to hop into my code editor and code along. That's that right there. It's like Google Docs. You'll be able to edit changes in real time. Let's see. So K could be anywhere up to 10,000. S dot length is only ever going to be 100. So feel free to come in and like work through this solution and write some pseudocode for it. I just want to like think about this a little bit. So you only have to iterate over the string once. 0 to n minus 1.
Mm. Mm.
Now I'm just thinking brute force. But I like your doubling idea because I guess it's not O of n if you do the doubling, right?
Yeah.
It would be, let's just say you double once, it's O of n plus n. If you double it 3 times, it's O of n plus n plus n. O of n, yeah.
That's
So
still O of n, right? Because O of 2n is also like 2 times O of n.
you're basically incrementing the power by 1 every time you double it, right? So like if you start at 100, then you double it to 200, it's 100 is n, 200 is n plus n, 300 is n plus n plus n.
Mm.
So it is becoming less efficient as you double it. We don't really know what we're going to be doubling it by. I still don't quite understand the logic here.
Okay, so since it's like in a cyclic manner, um, if k is like, you said, is k 1000 over there?
K could be
So
1,000.
yeah, k is 1000. So that means they want, uh, we want to replace the first character with the 1000th character that comes if we go in a cycle within that string, correct? So instead of going thousand times, you could just, divide 1000 by 10, and whatever is the reminder, that reminder would indicate, the string the character we are finding out. I can explain it with like, you can take an example. Say for example, uh, take this string, let's say software, software,
Mm-hmm.
and uh, take k as say 400 or 500, and when you divide.
Here, let me just write it out.
Yeah.
And what was that? String is software, and what was it? Okay.
And k is 400.
Mm-hmm.
Is k allowed to be 400? What's the k limit? Yeah.
Yeah, up to
So
10,000.
yeah, so what would be the 4000th letter after s, right? That's the question, right?
No,
So
no.
if it's in
Well,
a cyclic manner.
yeah. So eventually, basically, it's you're starting on S, and now
Mm-hmm.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 400. What's the 400th one?
Yes.
Yeah, yeah, yeah.
Yeah. So when you do 400 mod 8, is that 400 mod 8? Hold on. Let me
Mod
check.
8. Yeah.
400 mod 8 is 0. Okay. That means we take the 0th string as the 400th character after S. So after S, if you go 400 times, you'll again end up on S. Take, for example, 402, 402,
This
and
is for sure, for sure.
yeah,
Let's do 10 modulus 8 to keep it simple, right? So
okay, 10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what is 10 modulus 8? 2. So 0, 1,
Yeah,
2.
so that's,
All right, cool. Cool. So that works. What about
yeah.
15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And 15 mod 8 is 7. 1, 2. Okay, yeah. Yeah. How'd you know that?
So, because if it, I thought of like repeating the string k times, but I saw the constraint for k, we cannot repeat that string k times. So I thought like it's just like subtraction. Like division is repeated subtraction, right?
Mm-hmm.
Division. So we divide k by the length of that string, and whatever's the remainder, we end up at that place of that,
Mm.
character.
I like this. This is super simple. This is very simple.
Yeah.
This is O of n. You're never really doubling the string.
Yeah. I mean, I don't know how to come back to the, beginning of the, let's beginning of the string, like when I'm in a loop. So I always take the double and print out whatever it's coming, because when you double it, it's always within the range of that string.
Mm. So, all right, I'll go ahead and type the pseudocode. So basically, iterate over the string.
Mm-hmm.
Um, we're actually going to need another string though, right? Because strings are immutable.
Mm-hmm.
Iterate over the string. Um, find the character doing the replacing and add it to the new string. Basically, right?
Yeah.
Return new string. Okay. All right. Is anyone in my code editor and want to go ahead and do some coding? No? All right, I'll go ahead and do it then. Let I equals 0. Well, I is less than s dot length, I plus plus. Equals s dot length modulus k. Since we're going to use this so many times, let's just go ahead and so we find, well, it's not actually,
Oh, it's the opposite, right? Like k modulo L.
n-
Yeah.
well, K modulo L?
Yeah.
Well, we did K
Yeah.
modulo L. Okay. Yeah, that makes sense. But this is only showing us which one. It's not actually
Yeah.
giving us the
So,
character, so
so yeah. I was thinking of
this is
converting the string into an array of characters and then like then finding the index and then accessing that uh, character and creating a string and then join it and then return that string. That would be the encrypted string, like simulation. This is what Aditya taught me last week.
So if we do uh, 15 modulus 8 plus I, though, right? Because if I is 0, then we're going to be finding which character it is from 0. But if it's T,
Yes.
we're going to... So 15... So K modulus length plus I?
Yep.
Index. And then... SC. So this is the one that's doing... Or this is the one doing the replacing.
Mm-hmm.
S index. And then... Oops. Okay. So we're finding the actual position based on K and the length of the string plus its current index. We're figuring out which index it is in our old string.
Mm-hmm.
And we are just adding it to encrypted because we know this is starting from the 0 index, which is where we're starting. Okay. Huh. Alright, let's test this bad boy out. Oops. Encrypted. Oh man. What do we get? Nah, we don't have a debugger set up in here. You know what I want to do?
Mm-hmm.
I want to create a debugging configuration file and just have like a boilerplate data structure algorithm competition starter where I have a debugger already built into it. That would be cool.
Yeah.
It would just make it easier because now what am I doing? Like, unless, do you guys see any error immediately that stands out? Encrypted is coming back as, so let's see. We look here, we get T. That's what it's supposed to be.
Yeah.
And then undefined, undefined, undefined. So on the next, so the first iteration is working every time. Actually, the first one's working on the first one. On the second one, we have 2 working. So, all right, so what's the problem here? If anyone sees it, feel free to just yell out. So,
What's the range of the index we get? Is it between 0 and the length of the string plus I, right? So K modulo L gives us a range of 0 to the length of the string. And then we are adding an extra I to it. But we are searching for, an index that is not in the string. Say, for example, K modulo L is 8 and I is already 8, then 8 plus 8, 16. We just have a string of 8 characters, right? So
Yeah,
there's
yeah.
a issue there. That's why I thought of doubling the string. And then, like, I don't know.
So, but sometimes if we double, then sometimes we'll have to triple though. No. Let me see.
No, it's not necessary. We can just double it and then, yeah.
So it's T every time. Huh. All right. So this is just always targeting the same one. Hmm. Yeah, I see what you're saying. I see what you're saying.
How about we iterate this on a string which is of, double the length of the original string. So we create a string that is like s plus s. Yeah. And then work on this new string.
Just calling it strings. New string dot length. All right. So this will be double the size. Uh,
And we need to access the new strings index, right?
yeah.
That's the only change. And I think now we can keep.
Yeah. Okay.
I think it's you can keep it as I, like k modulo l plus I. Maybe that should work.
Yes. And actually, we don't want to go the whole length of the new string.
Yeah, correct. Half of it is sufficient, right?
There we
Yeah.
go.
Ah,
TDAR. TDAR. All right. It works. It's
I just thought of another solution,
uh huh.
but let's try this one first in Leetcode and see if it works. Then I'll tell you my idea after this if it works.
Accepted. Nice,
Oh,
nice.
nice. So
Yep.
my other idea was, since it is like it's going in a cyclic manner,
Mm-hmm.
we could just slice the string at that particular index, and then like, how do I put it? So let's take this example dart with k equal to 3. So we splice the index, splice it at index 3, meaning we take the t out and then separate dar and t, and
Mm-hmm.
then reverse them and just join them, because they're in the sequence, right? I think that will be much faster.
So what are you saying? So cut the string in half basically,
Not half, but
based on k.
yeah. And k here this time 3 is less than the string length, so it's like convenient for us. But this time I think we should splice it at k modulo l.
Mm-hmm.
So we splice it at 3 modulo 4, which is 3. So we splice it after r and before t, and then just swap, not swap, but put dar after t, and that would be our new string. This is another idea I had.
Mm. I got what you're saying.
Yeah.
And that would work for everyone.
Yeah, of course.
So with software,
And we
for
can
example,
test it.
we have a K of 15, a length of 8,
Mm.
so 7. 0, 1, 2, 3, 4, 5, 6, 7.
Yep, yep,
So the E.
yep. So it would be E software. That would be the new string.
Huh. And you only have to make one split in swipe like slice, I mean.
Yeah,
Huh.
yeah. I'm not sure if it is slice or splice, but yeah, that's the idea. Like if we know exactly where to cut the string, we can just switch the places. Like put E at the beginning of the whole string.
Let's go ahead and try it out.
Yeah.
So we could go ahead and just way faster too. I mean, this is a small problem anyways. With 100, this string is gonna be length of 100 at max, so it's a
Mhm.
very small problem. But you're right. This is O of 1, right?
Mm-hmm.
Could probably even return it just right there, and it goes to much simpler code as well. All right, so figure out where it needs to be split. Same thing, just like this, right?
Yeah, and L would be length of the string, right?
That would be the length of this string. Yeah. S dot
Yeah,
length.
yeah, yes, yes.
Since we're only using it once, we don't need a separate
Mm.
variable here.
Yeah.
And then, all right. So if we have S and we want to slice out a piece of the string, let's go ahead and do slice. And we're going to start slicing from the split index. And I believe we could just add this to, right? Shouldn't that be good?
I'm not sure about the syntax, but let me quickly check.
Because slices, the first index is where you're starting the slice. So if we're starting the slice on software, for example, at
Mm.
7, 1, 2, 3, 4, 5, 6, 7, we'd actually want to start it at split index minus 1,
Mm.
right?
Yeah, yeah,
Because 7 would be here. But so we're starting at 0, right? 1, 2,
yeah.
3, 4, 5, 6, 7. Nah, so that seems right. And then 0 to split index. So yeah, let's try this out. Yes, but we have a space here,
Yeah.
right?
Mm.
Oh, that's
Yeah.
because of this. There we go.
Mm.
All right, let's try
Now
this
this
one.
should be faster.
Way faster. Well,
Mm.
the slices. Well, technically the slice is O of n, right? And this is two slices, O of n. So this would be like O of n plus n, right?
Yeah.
And this
O of
would
n
be
plus n is still O of n, right?
O of n plus n. Well, you're not considering n a constant, though. I think you just cut out all the constants, but n wouldn't be a. Do they? I don't know, man. Some people probably consider plus n just n.
Okay.
Well, if n is a billion and you add another billion, it's not as small.
Yeah. True.
But I
True.
guess this is such a small problem. I would still consider it O of n. Yeah, it works. Nice, nice. This one's
Mm,
definitely, I feel like, easier to understand, cleaner,
yeah.
simpler. Yeah. All right, let's see what we got. We got the medium one now, right? Generate
Mm,
binary strings without adjacent zeros. This sounds fun. Let's go to 2. Man, no one even wants to hop into the code editor tonight. That's weird. Most people, uh, they hop in and code along. All right, we got another 2 examples here. I don't know why I had to copy and paste that. All right, what do we got here? You're given a positive integer n. A
mm,
binary string x is valid if all substrings of x of length 2 contain at least one character 1. Return all valid strings with length n in any order. Ah, okay. Hmm. The valid strings of length 3 are 0, 1, 0. Okay, okay. If all substrings of length 2 contain at least 1, 1. Hmm.
okay. The constraints are very small, but I don't know why it's medium.
Oh, yeah. So the valid strings of length 3 are those ones there.
Okay.
So you just need to. So basically.
Yeah, so it should not contain strings like 001 or 100 or 000. Hmm. Okay.
And then the second one, and output is 0 and 1. So are you incrementing from 0 to n, essentially, right?
Yeah.
And then. So the out.
No, from 0 to yeah, yeah. Yeah, correct.
And for each n, the valid strings of length 1 are 0 and 1. All right, they say length 3 times here. So the valid strings of length 3, the valid strings of length 1. Okay, so n is just telling us how long the string needs to be.
Yeah,
N
yeah.
is telling us what the length of our output strings need to be.
Yes, yes.
Okay. So we're only going to be adding strings with a length of n to our output array. Okay. And we're incrementing from the first, well, A binary
There
string
is
x is
no
valid if all substrings of x of length 2 contain at least 1 1. But if it's not length 2, why are we returning 0 and 1 on the second example if it has to be a length of 2?
So let's take the string 0 1 0 from the output of example 1. Okay.
Mm-hmm.
Now consider all the substrings of this particular string of 0 1 0. So uh, the substring of length 2, when you take a substring of length 2, that will be 0 1 and 1 0, which means both 0 1 and 1 0 contain at least one uh, character 1. You- Did you did
Yeah,
you understand?
yeah, I get that, but I mean in example 2.
Okay. Yeah, the valid strings are uh, of length 1 are 0 and 1. Okay.
But 0 doesn't contain a 1.
Yeah. So, but it's still valid because it doesn't have any adjacent zero. The title says without adjacent zeros. So, if we go by the title, then that is valid. And also, I'm guessing that the substring of 0 is 0 itself, and the substring of 1 is 1.
So we're just looking for any strings that don't have two zeros that are next to each other essentially.
Yes, correct.
Yeah. Okay.
And the second line is just a complicated way of explaining, what the title says.
Mm-hmm. So we're basically iterate over each binary string that contains n characters. Check the string to make sure there are no zeros in a row. Now, there's a way better approach to this. 100%.
Okay.
Because this is
Okay.
this is what I'm talking. Because if you iterate over the binary string, let's just say we figure out what these binary strings are. We get an n of 1. We know that we could only look at binary strings that have a length of 1, right?
Mm.
So 0 and 1. Those are the only ones. If we have 3, we know we could look at any of them that have. So would you consider I guess 0 0 1 would be 1, but you could consider it that, but that has two adjacent zeros. All right. So let's think about this.
I have a solution, but it's so bad that it's it would reject it. The idea is to actually generate all those strings. So let's say n is 18. So we generate 2 to the power 18 strings. And then on each of the strings, we apply this sliding window to see if there's a 0 0 in it. And by the time we reach the first 0 0, we discard it and go to the next possible string.
Okay, so if we have
But then you will have 2 to the power 18 strings.
Yeah, it's exponential. It's like O of 2 of n's, like very bad.
It won't pass
Yeah, it won't pass.
for sure.
so if we get 5 if you said n to the power of 18.
Yeah. So if you have like a valid string, think about if it start with 0, you want to increase it by 1, so you can append 1 before the 0, but you cannot append 0 before 0. And if it is end with 0, you can append 1 after the 0, or just you can only append 1. But if it start with 1, you can either append 0 before the 1 or 1 before the 1. So start with the valid with length 1 and generate from it the valid with length 2. Then generate from it the valid with length 3, and so on.
Okay. And so on until we reach
N.
length n. Got
Yeah.
it. Okay.
So yeah, it's passed. It's slow, but like it passed the test.
Okay, that's really fantastic. Love that idea.
Yeah. By the way, 3 is easy relatively. But
Oh.
like, but like I'm still working on it. So, yeah. Not sure about 4.
Okay.
So what exactly was he trying to do?
Yeah,
4.
so I'll try to explain, Omar, if you allow me.
Yeah, sure.
So you can check if I got it right.
Mhm.
So basically Omar is saying we generate those strings. So since we do not want to have any zeros like twice, we
Mhm.
start with we start with strings that start with 1. So we start with 1 and then we append either 0 or 1 next to it, or we append 0 or 1 before it. So we can choose one way to construct a string. Let's say we append a 0 next to it, and we have to make sure the next appending should not be a 0, it should be a 1. So it's like that. So in the first go we generate strings of length 2, in the second go we generate strings of length 3 until we reach n. Is that right, Omar?
But if you need strings of length 3, why don't you just start with strings of length 3?
You can do that, but it's like we need to make sure the substrings are also don't have edges and zeros, right?
Mhm.
I mean,
Yeah, true,
yeah, you
true,
said
true.
we can start with length 3, but we have to make sure the strings with length 2 also should be valid.
Yeah, I see Omar typing too. Mhm.
Is Omar
Mm.
trying
Uh,
to say something, or it's like,
yeah, he's typing right now. So
Yeah.
you're starting with 0 and 1.
So this was
yeah, go
length
ahead.
equal to 1.
Yes.
Now, then was length equal to 2. So now let's say like we want to generate the valid strings with length equal to 3. So we take the first string of length equal to 2, which is 1 0. So now to make it length 3, we need to append either 0 or 1. So we can append 1 before this one, or we can append 0 before this one, without violating the condition of having at least one digit adjacent. Now we have 1 0. We cannot append 0 after the 0 because then we will have 2 zeros.
Mhm.
So we can only append 1.
Yeah.
So this single element become these 3 elements. Now we do the same with this one, so we cannot append 0 here. We can only append 1, and we can append 0, and we can append 1.
Mhm.
And finally we do the same with this one. So we can here append 1, we can append 1 0, we can append 1, and we can append 0. So for sure, when we have this like when we move from length 2 into length 3, we store those into a set, so that
Okay.
we remove the duplicate. Then we make this set into array. So
Oh.
then we move into n equal to 4, the same thing. We iterate every element here, and we generate all the possible value,
And
and
this
so on.
and this one worked.
Yeah,
Mhm.
it's very brute forced, but like it works.
And I have a question. So the set operation and converting it into an array, does it take lot of space, like lot of time complexity? Does that
I
add
think
to
it's
time
O of
complexity?
n.
Okay.
So you can use array.from and you insert the set here. So it generates the array. So it should take O of n. Because the set, not O of n, sorry. It should take whatever the maximum possible solution, time complexity. Okay?
Got it.
So what if you have an n of 5 though? Are you you're not building the strings for every level n equals 1, n equals 2, n equals 3, because here you
No,
build.
I built it for every level. So you can see like, can I post my solution or it will spoiler? You don't like spoiler.
Nah, go ahead if you want. I'm curious to see how
So yeah, I start with the valid 0 and 1 for length equal to 1. Then iterate from 1 to n and create a new valid. And now for every element of valid, if it start with 0, I append 1 before it, add it to the new valid. If it start with 1, I append 0 and 1 to the new valid. And I do the same thing at the end of the valid. Then I reassign valid to be array from the new valid set. So once the for loop done, I build the levels one by one until I reach to n.
Is there a test case where it says n is 18?
I don't know.
Okay. It must be. It must be in the test cases.
Yeah,
Like,
I believe so, yeah. But it
yeah,
is
it
like
works.
dynamic, it's like dynamic programming because
Yeah.
it's similar
sorta,
because
yeah.
you build on top of the result of the previous
Previous.
layer.
Yeah. Correct. Correct. Yeah. Impressive. I love this.
Yeah, I like it too.
Yeah.
So if it starts with a 1, you're adding a 0 and a 1. If it starts with a 0, you're just adding a 1. And then you do the same thing. You check if it's ending with a 0. If it's ending with a 0, you just add a 1. If it ends with a 1, you add a 0 and you add a 1. You're creating 2 strings. Huh. So it's using... How much memory is that using?
I didn't care. I just got it and submit. But I think it's very brute force approach. But the thing is, remember, like, what motivates me into it, like n is equal to 18. It's very small input size.
True. True. At what limit would you be stopped though? Like, if n was 1,000, would you still be able to do this one?
Let me see. So the thing is, this operation, when you add 2 strings, it's rebuild the entire string. So if n equal to 1,000, I want to prepare all the strings to be an array of character. You know what I mean? Because if you have like, if you run this operation, this will take nine steps because it's kind of creating a new array in the memory.
Yeah. Yep.
So this is what I would care about for large input. Like instead of making it like just brute force add, I need to do something like string builder or so.
Mm.
Um,
Also, if n is 1000, the strings will get like exponentially bigger, so it would take
Mm-hmm.
much more memory, right?
um,
And the number of possibilities also get like bigger.
mm, maybe for n equal to 1000, I would start thinking about representing the string using binary number instead of representing it in strings.
Hmm.
Because you can, like, for example, 10, you can represent it with 1 and so on.
Yeah,
So I
yeah,
think for large number, I would start thinking about this, but it will be much, much harder.
Yeah.
true. It becomes a math problem.
There's probably people who use binary for this solution. We'll check afterwards. All right. Well, this solution is clean. Let's go ahead and check out number 3. Unless does someone else have another solution for this one that they want to share?
I did it using backtracking. So
Backtracking.
yeah, I mean what Omar did, I just did it. Omar did iterative, I did recursive. That's the only difference. Because that was like I felt it to be easy for me to understand.
Mm-hmm.
I can share it. I mean I'm just making some minor changes. Like Omar said, I did it using not didn't use Spring Builder. So I'm using that now. I feel like that might make some complexity better. I also wanted to just make it run. Also, you don't need I didn't need a set to remove duplicates. It didn't create duplicates. I don't know how.
Yeah, because when you use recursion, there is
Yeah,
no like
No,
there's no
it
need
still,
for.
I mean, it would still like create those duplicate combinations, right? Like I actually did it using a tree. If you see my code, like I actually try to form a tree and see if it creates a duplicates, but it didn't create any duplicate. That's why. So I'm not sure. That's why I didn't use a tree. I felt like it's not creating duplicates, but yeah, I mean, it's the same logic exactly. Like I have the main list, and there's this thing, string builder thing, and I'm starting with like index 0, like how many characters to put. So the 0 would go till length n,
Hmm.
and then after that, this is my base case, where if that idx crosses n, it can be just equal to as well, but yeah. And then it will add it in the result and it will return the value, the substring which I found. Otherwise, there's one case where if the previous value is 0, then just you can only put 1. But if that's not the case, then you can put both. So basically, I would have like at every level, I would have max 2 recursive calls and minimum 1 recursive call.
Hmm.
So at every state, I would have 2 recursive states or 1 recursive state.
Mm.
So yeah, so I think that was like that's how I did
Hold on. Go up.
this.
Go up real quick. Right there. Higher. Yeah, right there. So that's the helper. Only when the index is greater than or equal to n. Result dot add substring. Okay.
Means I have found
So
my
you're
substring
only
basically.
you found the substring with the length you're looking for.
Yeah, that is
Essentially.
length they have given 3,
Result.
like n basically. Sorry, yeah.
So you're adding it, and then with those appends, you're just actually creating. Okay. Okay. Yeah.
Yeah.
Cool. Nice. That's clean.
Aditya, can you show me the tree once? Okay,
So initially
so
empty, that creates 2 states, 0 and 1. From 0, there'll be this cannot be actually a state because if previously
mm,
0, then it has to be x. So at this point, at 0, there'll be only one state, which is 0, 1. Now from 0, 1, there'll be like two more states, which is 0, 1, 0 and 0, 1, 1. Because since it is 1, so it's fine. Like it can go for 0 as well as 1. But when it is 0, then my next character has to be 1. So that's the condition.
And then you're removing the character after.
Yeah, because like that's the recursion, right? I mean, because
yeah,
for the next state, I need to go up. Like when I'm going down in the recursion, when it returns the call, it needs to go up so that it can put the next character. So I have to remove it. Otherwise, it will like keep on appending down. It won't be like going up. Like it will use the next. I have to remove it for the recursion.
Yeah. So I see a pattern here. So it's like 0, 2, 4, and 8. So what's happening? Why we don't get duplicates is because of the X here.
Yeah, I know,
So
understand. Yeah. So that's why when I draw a tree, I understood that it's not going to create
yeah,
duplicate.
it's automatically. Yeah, it's automatically. Yeah, we are
Yeah.
automatically getting rid of those duplicates. Cool,
Yeah.
cool, cool.
Yeah. Yeah, so this one still seems I think just recursion is memory intensive, right? By nature.
Yeah, it's used in line stack.
But
So
less memory than Omar's solution because Omar's saving doubles, you're not.
I mean, this toString function, I am not sure because if I remember, this creates an additional string, I think, to copy to the string object. So this like is kind of extensive, but like my append is O of 1, append and delete. So I feel like it would be like the complexity would be the uh, number of combinations, but for every combination there'll be like one more additional n factor to copy the entire string builder to the string.
Yeah, that makes sense.
So usually in interviews you don't mention this part, but it's better to mention.
Yeah. You guys are good, man. I love this. I love seeing this.
I got stuck in third. Like
What is the third?
Omar said third one was easier.
No,
This is the third one right here.
I said it's relatively easier
Oh
than
yeah.
usual third one.
Oh, yeah.
I got for some reason like I'm stuck at certain condition. Like I came up with the logic. It's a DP from what I understood,
I'll be right back.
but I'm not able to like. I got stuck at one point. I'm using like X count, Y count to keep the track of X and Y values, and then I'm using these two arrays matrices to calculate the DP array.
Okay. We haven't really like gone through the question yet.
Yeah.
So, what's
I mean,
what is it asking?
okay, so uh, it is what it is doing is it is telling like you have this, you will be given like this kind of matrix
Mm-hmm.
where it has X, Y, and dot. Now you start, so you need to find return the number of submatrices that contains the first grid. It always need to have the first grid, and it should have equal number of X and Y values, and it should have at least one X in that submatrix. So for
Okay.
example, in this case, for this question, this would be one matrix. Uh, this is going to be one matrix, and this across is going to be one matrix. So there are three submatrices. It can't create more. It cannot have this submatrix because the count of X and Y is different.
Yeah. Yeah.
So that's the question. You need to count the number of matrices. It looks easy. I mean, it is easy actually, but I don't know where I'm stuck. So I feel like I'm making it a bit long, but I still feel like this logic should work. But yeah, I'm going to try doing it on my own.
Yeah.
Like I have some,
Yeah.
I'll just stop the screen.
right, what do we got here? Is the third one hard? Oops, not that one. Count submatrices with equal frequency of x and y. Can you hear me?
Yeah, yeah.
All right, so given a 2D character matrix grid, where grid I and j is either x, y, or dot, return the number of submatrices that contains grid 0, 0, an equal frequency of x and y, at least 1x. Okay. So we're looking for grid 0, 0. We're looking for an equal frequency of x and y. And at least 1x. Okay. So if grid 0, 0 is x, we know we have 2 conditions met, right? So we have 3 conditions.
Yeah. Yeah, 3 conditions met. Yep.
Yep. For each submatrix. So submatrix is going to be elements in a row, right?
Yeah.
But it's not going to be, for example, in this one here, if the first one was x and the last one was y, that wouldn't count.
No, because then they're not of equal frequency, right?
No, they would be. Like if grid 0, 0 was x and grid 0, 2 was y, and the dot was in the
and
middle.
Oh, okay. If the dot was in the middle, then that would be the entire row would be a submatrix, possible submatrix.
Okay. Here we have 0.
So I think it's enough if we just check the first row and the first column. No, that doesn't work.
Well, what about in this one here? So we have, let's just say, our submatrix. So we're checking. All right. I see what's going on. So we're gonna check. So we're checking x, x, y. Are we also checking like grid 0, 2 and grid 1, 2 as a submatrix?
0, 2 and 1, 2.
These two.
We can check it, yeah, but they have to meet the conditions, right?
Yeah. But then, all right, so how about down here in example 2? We're checking, let's just say we're checking x and x as a submatrix. That
So
is
that is
not meeting our conditions. And then let's say we're checking x and x, the column. That's not meeting our conditions either. But 0, 1 and 1, 1 with x here and y would be underneath it.
Yeah. And that also doesn't meet because the top left corner must be in the submatrix. So
Okay.
yeah.
Huh. Why? Why does that have to be in the submatrix? It doesn't say it. By choosing all cells matrix XY, where x1 is less than or equal to x, which is less than or equal to x2, and y1 is less than or equal to y, which is less than or equal to y2. So why would grid 0, 0 have to be included in the matrix? I'm just curious. All right, so it could be up to 1,000 by 1,000 matrix. Grid IJ is either X, Y. Okay. Do you know why this grid zeros? Oh, right here. Gotcha. Yeah, so we have to include the top left. All right, so we basically want to find. So we're only ever checking the top row and the left column, right? Yeah. Okay, so now I see why this XY doesn't work here. All right, so if it's an X in the top left, I'll go ahead and just start taking some notes on this. Okay. And it could go anywhere up to 1,000 across and 1,000 down. And all right, so we just need to return the number of valid matrices, right? Every time we encounter one, we can go ahead and add it. Return result. All right. Now the logic. So we need an even number of x's and y's. That's what I would say is the most challenging one here. Up to 1,000 is really not that big either. So So if we have a matrix that looks like this. So this would be one valid, this would be one valid, the output would be 2. But if we had another x here, so this would be 1, 2, 3, right? We'd include that other one there. I'm thinking of a brute force solution, but there's got to be something better. Because we could always just iterate over the rows. So I'm going to go ahead and type out just something brute force, and if anyone has any other ideas, feel free to just shout out. Not over, but across. Okay, so I'm just gonna say, since we're looking for the same number, we could just compare them at a given point. And then when we iterate from top to bottom. All right, another thing I want to do is go ahead and just get the length of a cross equals grid dot length and grid dot length. Okay, and the conditions, we need to include grid 0, 0. We need at least one x. So if x, all right, so there's a couple conditions here, right? If while iterating x is 0, the matrix is invalid. Also, x is not equal to y. X is 0. X is not equal to y. And we know that grid 0, 0 is going to be included in it no matter what, because we're just basically iterating across. So if we do something like for let I equals 0, while I is less than across length, I plus plus, and so we're gonna need at least 2, so we'll start at 1 here, because we'll go from alright, so we just need to figure out what we're starting with too. Alright, so we're already gonna know what grid 0, 0 is. So we could say, let me just use this as an example. As we're iterating across, we have x here, so we know x is going to equal 1, y is going to equal 0. We need at least 2. So we could always just check what 1 or what the 0 index are and what the 1 index is, and start with that. And then as we move across until we get to the total length, we just vary these based on what we've encountered so far. And as long as x equals at least 1 and they're both matching, then we could go ahead and increment the output. Because it seems that if we need to include grid 0, 0, okay, we're also going to have to be checking the center of the matrix too, which I'm leaving out right now. Does anyone else have any thoughts on this before I continue developing it? Sir, yeah, I can't hear you, man. I think I see you trying to talk, but your mic's not working. Is that the hard one you're working on, Omar, or is that the second medium? Is that the second or the third one, Omar? I mean, is that the third or the fourth one? I can't hear anyone, so maybe it's me. That's strange. Can you hear me now? Hello? Hmm. Hey, can you hear me? Hmm. Hey, can you hear me?
Yeah,
I don't know
yeah.
what happened. My Discord just the audio went blank. I wasn't able to hear you guys, and I thought I saw
Were you
you.
speaking the whole time?
I was talking the whole time.
Oh man,
Yeah, I didn't know
oh
where
man.
I didn't know where you guys went. Then I realized like, man, it's awfully quiet in here. I'm like, Omar, you working on the hard one? No response. I asked you a question. I saw you were talking, but I couldn't hear you. So I'm like, what the heck's going on here? All right. Does anyone have any thoughts on the third one? I was kind of thinking through it out loud, but it looks like nobody heard anything I was saying. Um, I see them working on some solutions though. Are they posting? Are those solutions they're posting the third problem?
No, these are for the fourth
Uh,
fourth problem.
okay, nice, nice, cool, cool.
Third problem, I got like a very small idea. It's like basically constructing the matrix from grid 0 0, and once we hit one valid submatrix, we start again creating a new submatrix from that one. So basically DP. Mm. So that was my idea, but I don't know how to implement it, and also I don't know if it's the right way.
Yeah, I
The
was
fourth question, yeah, yeah. Please go ahead.
I was thinking at first that you just had to iterate across the you just had to keep track of across the top and across the left, but you actually have to build out. So like it can't just always be one level. It needs to you're eventually going to have two levels and three levels and four levels and all that. So I just that's where I was starting to think through.
Mm. And for the fourth question, I I was instantly reminded of the knapsack problem. So that's the basic dynamic programming problem.
Mm-hmm.
And that's all I had. Fourth, I'm stunned. These
Gotcha.
guys were able to solve it. Omran and Fernando.
The fourth one?
Yeah,
Nice.
Omran just posted the solution and got accepted.
Nice, nice. Cool, cool. I'm curious to see the solution if he's gonna. Oh, yeah.
I don't even know what a tree is. It try? How do I pronunciate it?
Try? Tree? I don't know.
Tree data structure.
Go ahead and just wait, share some solutions. What did everyone else think? Let's see. Areli, Electron, Musty G123, Ian. Thoughts? Comments? Okay. Cool, cool. Well, we'll just wait. I'll go ahead and. They'll be coming back into this room in just a minute, so. What's up? What's up? How'd you guys do? Can you hear me? Hey. Hello. Seriously?
Ah.
Hey, sorry about that. My mic keeps cutting off for some reason. I don't know why. How'd you
It
guys
was it
do?
was just
Yeah.
literally that last little hurdle. I couldn't figure out what exactly they needed. So I guess the answer is just one solved.
One solved?
Oh.
Nice, nice.
Unfortunately.
Omar shared his second solution with us, so technically we have one solved too. Though Surya came up with both of the solutions. So congrats on that, man.
That was easy. The first ones are always like easier.
Yeah, yeah. They're supposed to be, right?
Yeah. Is Ayappan still in the room? Is he with us, or do we?
Who?
Should I bring him? He's in breakout room 1.
Oh, yeah, yeah, yeah.
I'll go and like call him here.
All right, sounds good. Does anyone have the first solution that they want to share?
Sure, I can share mine. It's not that it's the easiest one, I guess.
Yeah, that's cool. Todd's sharing the first solution.
I'm not sure how optimal it is, but you know, it passed all the tests. That's all I care about.
Let's see. So you start with an empty string. I believe we did that in the first solution. Index character and enumerates S. So you're basically iterating over the S string with that, line 4.
Does anybody have the second solution?
Oh yeah, let me share. But
Hold on one second. So with if new index is greater than or equal to length S, then new index equals, okay. So if the new index, okay. Yeah, so we handled that one differently. We doubled the string in the beginning. Surya suggested doubling the string. That way, if the index was ever greater than the length of the string, it would always just go over into the next,
I
the
see what you
second
did.
half of the string. Basically, was
I mean
really
that's
clever.
not too different. I think this solution is pretty straightforward. We'd all have like a similar approach to it, right?
Yeah, yeah. Well, actually, Surya came up with an even better approach next. I'll go ahead and share my screen and share the code really quick before we
Yeah,
move to
throw
the
that up
second.
there. Let me see.
Surya, you want to share it?
I don't have it with me. I haven't really written it down. It must be.
It's right here.
I haven't really submitted anything. I'm just like writing down stuff in my notebook.
Oh, yeah, I'm sharing my screen right now. The code that you suggested.
Okay.
You can see my screen, right?
Yeah. So basically, we are we are going, we are traversing the string in a cyclic manner. So I thought if it is cyclic, we could just split the string where it exactly needs to split. Like uh, if we we can observe a pattern. If we take few examples, like we did it for software, and we tested it, and this value split index equals k modulo s s dot length. Now this value is where the string needs to be split, and we just reverse them and attach them again. So it's like dart, and when k is equal to 3, we split it at r and t, and we just reverse them, so it becomes tdar,
Mm-hmm.
e and dar.
With
That
this
is a great approach.
with this software right here, you could see that k, we set k as 15 and the length of the word software is 8, so we just did k modulus 8, which splits it here, and then you just take the first half of the string and put it after the second half.
Yeah, because this is still again a cycle, like a cyclic thing. Imagine all of them in a circle, like on a wall clock. That's what I did.
Yeah, it was clever. Nice.
Yeah.
Does anyone have any other unique solution to problem 1?
I'm not sure, but I can share whatever I have.
Yeah, sure.
Let's see.
Sure.
So it's just an what do you call it? Arithmetic calculation for cyclic logic, wherein you will go to location wherever it is, and then you do the length you want to pass through, and then get a mod of that length. It gives you the value of that particular index value. So I just appended it into the characters where it should be, into the new array, and that's it. Just came out.
And this is incredibly fast. It beats 100%. That's cool. Oh yeah.
Nice. So you store it in an array, and then you just join all the strings within the array. Okay, nice.
Yeah, initially I was just printing that, and it gives the characters list, right? So it just keep failing. I didn't understand why it is failing. Then they're expecting the string instead of character array. Oh yeah, when I put that one, it worked.
Nice.
Join will give you a string again, right? Yeah.
Yeah.
Nice.
Nice. Cool.
Thank you.
Anyone else? Or did anyone solve the second problem?
I did.
You want to share?
Oh yeah. Suddenly, this one moved to somewhere here. Okay, yeah, I'll share now. So here is the second. I'm just trying to get this one done, but the use case 1 got succeeded, and yeah, this is the logic I just put in there. I got the Cartesian product of all the values between 1 and 0 for the n repetition. For example, if you want to do it for 3 count, 5 count, 6 count, so you can have to replace the repeat value. This is a built-in function, by the way, or a package that we can now use the product. Once we get the list of values, then it's just an iteration, iterating to each list, and go to the position of each list and check the current position and then the next position, that is length of 2, right? The position should be 1. So when it is 1, well and good, have a flag equal to 1. If it is not there in any one such case, become 0, and then exit that loop. If it is 1 at the end, you just append it to the main string, that is the list, and that's all the output comes out at the end. when that particular conditions matches. Length of the second string has a 1 in there.
Okay.
It's just a for loop magic in all data structure algorithm that we use.
Does this hold on? Is this a working solution?
Does it
Yes,
work
except
for n equal to 10 or any higher number?
yes, it does work except that 1. So that's where I'm trying to put
Oh,
my,
you could just put it in a edge case, right? Like an if else block.
yeah. I was doing it in my local machine and copying the code, so I have it there. I need to
Oh.
put in the. If I have other number, right? I did test it with the other screen. This one, how do I change the test case?
You can
Here.
click the plus button there and it will give you
No,
a new
here.
test case. Oh, okay,
Test
okay.
case, yes, here. After completing the
Oh, yeah.
whole course, then it becomes what is the, yeah, that is.
Oh, nice. Nice.
Nice.
What happens if you put n equals 10?
It will go, but since it's there, that crazy thing will happen. It will big O cut.
Mm-hmm. Cool. Anyone else? We have a solution to number 2, but
For example, 1. That's a very simple
Okay,
first query. Right?
okay.
It doesn't work. So I will just add this guy here.
Okay,
If
okay.
it's a 1, and then I would put a 1 and a 0. That's it. What do you call
This
that?
is
And equal to 1. I need to enter 1. Then. Equal to.
did anyone else solve number 2?
Yeah, I solved number 2. Let me share my screen.
Sure.
One. Okay. Yeah, this one. So for this one, if you can check this binary this group this strings that contains ones and zeros is like a binary numbers with this size, you can realize that you can use this topic. It's bit mask. That's the word. Yeah, it's something like that. I want to share this after I explain. So when you have this number and it says like you have to find this can you hear me?
yeah, you just went silent, but now we can hear you. Yep.
Okay, so when you have
Oh.
these numbers, you can realize
Mhm.
that you are going to have this possible um, group of numbers with zeros and ones, and you can realize that this gives you like 8 possible combinations. That's 2 um, power of 3. Yeah.
Mm.
So let me. Yeah, that's. Um, yeah. So that's 8, and we can just build these combinations and check if for each one, because build these combinations is going to take you like 2 number 3. So the biggest case is going to be like 2, and
Power 18. Yep.
yeah, and that's not a big number.
Oh, okay. Okay.
It's
Okay.
big
Okay.
enough.
Cool.
Yeah, and you have to check this amount of combinations and just verify if there is at least
Yeah. One
one,
pair of zeros, we discard it.
yeah, one pair. Yeah, if we have at least just one, and this is an invalid combination because it doesn't contain at least one, either here or here. This also,
Mm.
but this is a valid
Valid.
combination because it has a um, substring that contains 0 and 1 and 1 and 0. So yeah, in order um, to build these kind of combinations, you just need to convert this uh, number into a binary one, because it's just like 3. The its representation is just this. For 4, it's just this. For 5, this, and so on. And yeah, so I just established it. I just declared this valid strings array that's going for strings, and build the binary string. It's going to start with empty. I don't need this. And I just going to build the binary string with this size. And this operation, why I'm doing this? This operation means I'm going to convert 5. This means I'm going to check 5, and for the first bit, that is 0 in the position 0, the second one in the position 1, and the third one in the position 2. And this operation is just similar to make this. It's like you are taking this into a binary number. Even
Bitwise operator.
yeah, even you can even you can convert in Python, I think, but
Yeah.
it's
Yeah.
just
Yeah.
for another languages. I started with Java, so I just know that this means you move one, just one position. The In this case, sorry, 0 positions, so it's the same like this, and you verify that this operation is going to return 1. Yeah, because it's just doing this.
1 and 1. Yep. Yes.
Yeah. And that is going to be just 1. Yeah. For the second one, it's just you take the same, but you move to the left just 1 position. When you move to the left, you leave a 0. So the same goes for this one. 2 zeros,
0
2
0.
positions.
Mm.
This is going to return 0 because it's just something like this. So in this case,
1 and
um,
0 0, 0 and 1 0,
yeah,
1 and
it's like, yeah,
yeah,
this is
it's
going to be,
0 basically, all zeros. Yep.
yeah. And the last one is just going to be 1 because we have at least this one. So yeah, you can build this, and you can realize that this is going to from 0 until 2. That is the size or the value of n minus 1. So that's why I'm going from 0 to the size of n minus 1, and just doing this operation. If this is true, add 1. In other case, add 0, and I'm going to check if this binary string that I built is a valid combination or a valid yeah, if it's valid with this condition. Yeah, and that's the easy part. So the difficult part is just to build that set. I think for Python you have this. So just this.
Yeah. It will return the binary representation of that number, right?
Yeah, I think we can reduce this even. You don't need that if you are working with Python. For JavaScript also we have one function, but I don't remember. Like this is going to be and this is you're going to go from this, the length of the binary string minus, yeah, so that must be the same. I think there must be something weird. Oh, I remember. For Python, the first the first 2 characters are zero and B. Yeah, that's weird. It's like some standard. Yeah, 0 and B. So you just need to put that part. Yeah. Oh,
So it returns a string, right? String, or does it return a binary number? No, it returns a string. Yep.
yeah.
So
And
where is it?
we need to know also um yeah, is equal to, I think it's weird. sorry. Hmm. Yeah, we need to add some zeros.
Why do you use string when you can check with integers only? It's kind of waste.
Yeah. Yeah. But yeah, that's was my solution. Yeah, I tried with integer, but I just submitted the first thing that it came to my mind. Yeah.
Nice.
Yeah, but that was my solution for the second one. I need to
Fernando, where does the bit masking coming to picture? So which part of this is bit masking?
just building this part
Uh,
bit mask operation. Yeah, just building this
okay.
little piece of operation. Yeah.
Cool.
It's an interesting one. I
Yeah.
didn't think about it.
Yeah.
Does anyone else have another solution for the second problem?
Todd said he solved 90% of it.
90%?
Yeah.
We do have Omar's solution too, but I don't want to share someone else's solution. He came in and he just kind of, I liked it. I like his solution though. Well, Aditya and Omar both had a solution. Aditya decided to go with recursion, where he was building out strings, I believe, and returning only the valid strings. So he was basically adding 0 and 1 to the end of the string continuously as he went deeper into the recursion. Omar had something very similar, but it was an iterative approach. Right?
Yeah.
What was
So
there was a
because
big
of
difference
that,
though, right?
yeah, it generated duplicates,
Yeah.
and he had to put the set function on it to remove those duplicates.
So Aditya didn't have any duplicates and he didn't have a set.
Yeah.
Nice. Cool. Anyone else?
Martin is here. Hi, Martin.
You're muted. I don't know if you're trying to talk. Did anyone solve number 3?
Hey guys, was it number 2 or 3?
We were just on number 2, but I was moving in number 3 because I didn't hear anyone say anything.
Can I share number 2?
Sure.
Give me a sec. It's titled what? 3211, right?
Yep.
Generate binary strings. 328. Yep.
Yeah, 3211. That's right. Yeah.
Just give me a second.
Yep.
I would say the generating the binary code is the first challenge, right? So once that is done, rest can be second part is kind of check validating in two values, two positions. Yeah. I submitted my second one. It got submitted. So I just hard coded for value n equal to 1 is 0 and 1 the coded string. So that was done.
Nice.
I just shared a link to my code. Can you guys see it?
Mm-hmm.
So
Yeah.
when you want to check a substring of length 2, all you have to do is shift by I and take AND operation with 3. Do you guys understand why? So that's line number 10.
Mm-hmm.
Because
Where do
3
I see
is,
the code?
I just shared the link to the chat.
Oh, okay.
Can you guys see the code?
Yeah, I can see the code. Yeah.
Yeah, so line number 10 is checking a substring of length 2, whether it has at least single 1. Do you guys understand why line number 10 works? So you understand
Because
line number 7, right? You all understand line number 7, right?
7. Yeah, Fernando just explained what 1 and
Yeah. Line
double
number
plus
7 is
less
just
than.
iterating over all mask, right? All mask from 0 to 2 to n minus 1. And line number 10 checks whether it has a substring of length 2, which is 0, 0. Does that make sense?
A substring of length 2 that has 0, 0. Yeah.
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 Why
So
did you put 3 over
line 2 is
there?
finding doubles.
Because 3 is 1, 1. If you take AND with 3, then it will give you like just 2 number. So if you take mask shift I and 3, that will give you either 0, 1, 2, or 3. Does that make sense?
Yeah.
Yeah. Yeah.
And if it is equal to 0, then you have 0, 0. Otherwise, it's either 1 or 1, 0 or 1, 1.
Mm-hmm.
Does that make sense?
Okay. Yeah.
So yeah, if you take AND with 3, it's very simple. Like you don't have to deal with all the hassles. Okay.
Yeah.
Got it.
Yeah.
So if your flag is okay, if your flag is true, then you add your string to the answer. Otherwise, do nothing, and that's it.
Huh.
Good.
Okay.
This
Then
is
where's
so
the
good.
string? Oh, line 12 to. Okay. Yeah.
I'm sorry, what?
No, I was just saying where are you adding the string, but I noticed from line 12 and on. Okay.
Yeah, from 12 to 19.
Okay, and then you just yeah.
That's it.
Cool. This
Very
is
cool.
C++. Yeah. Cool.
Yeah, of course.
Of course. You don't ever use any other language?
I use Kotlin, Rust, Python, Java, but when I do CP, I only use C++. Sometimes Python, but mostly C++, like 99%.
Why do you choose C++ over another language for Leetcode problems?
It's kind of de facto standard. Like there's no reason to choose other language. At least it is the best. Like it's the de facto standard in the area. The only alternative that I can possibly choose is Rust. But other than Rust, like I don't see any reason why choosing other language.
Do you use the
Gotcha.
same do you write the code in C++ even for the Code Forces contests and stuff like that?
Yeah, of course. As
So-
I said, it's a standard. Like there's no reason like to choose other language than C++. Like the only like alternative, as I said, could be Rust. Rust is as efficient as C++, but any other language is not as good as C++.
Yeah, every time I watch a video of the top competitive programmers, they're always using C++. The only other person I know who's as good as you, Martin, is probably Josh, and he's just mathematics all day, man. He same thing though. He would use Rust, and then sometimes, well, he would do the problem in Rust first, and then he would do it in C afterwards. So he was kind of just solving each one with both of them, kind of just for the practice, which was cool. Cool. So industry standard. Does anyone have number 3? Fernando, did you solve 4? Did you solve the fourth one today? Someone said you did. I was just curious. I can't hear you.
I solved just 3, not 4, but Omar solved for the fourth one.
Gotcha. Yeah, he posted his solution here too. Did anyone solve 3? I know you did, Fernando. I don't know if you want to share, but just seeing if anyone else did, because I know you already shared one. No one? Fernando, you want to share yours?
Yeah, I can share. Let me
What was that one?
share my screen. It's not.
Oh, yeah. I think Surya had a solution for this too, but you didn't code it up, did you?
Which one? The third one?
Yeah.
No, I didn't have I had a partial solution, like just an idea,
Mm-hmm.
like starting to build the submatrices from the corner. That's just about it.
Mm-hmm. Mm-hmm.
Yeah, for the tier 1, I just built some two matrix to keep the numbers of whiles and x. Let me explain this part with yeah, like this. So as the problem was this part, it mentioned that there is some submatrices where the frequencies of x and y are the same, and at least there is one x. So the approach was using some basic dynamic programming. So I just noticed this, like you can just convert this, like how many x and y's have for each column. Like starting with this, you have just 1x, and for this second one, if you want to build some kind of submatrix like this, you're going to know that you have 1x to the left, so you need to move this amount. So you're going just to copy that value and so on. And you need to another 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 matrix, but this is going to represents the numbers of whiles. So I'm going to say this is for the x, and this is going to be for the whiles. So I'm going to count. This is just 1x, this position. I'm going to move that amount to this position, and so on. Now, below, you need to know that you have at least 1x. So you have 1x. So you are going to copy that, and for this part you're going to also copy that, because you're going to have some kind of, this is just some kind of square, so you know in this area you're going to have 1x. And yeah, I think was something like that. Let me check that. Yeah. And the same goes for this one. Now for the whiles, you know that in the first cell isn't any it isn't any while, so it's 0. For the second one, you have at least one while, and you can copy that. For the below, you don't have any while, so you have one while, so we are going to copy that. And for this one, you are going to copy that, but remember, you already have one up, so you need to increase that, because you are going to have 2. So one is coming from the left and one is coming from up.
How did you know the difference? So, all right, if you look at the matrix for the x's, if you look at position 1, 2, highlight over that one. 1, 2, the one on the bottom in the middle.
This one.
Yeah. How did you know that that was a 1, but with the y's in the same position, the 1, 2 position, it's a 2? So how did you, what's the logic where you decided that one was going to be a 1 and one was going to be a 2, even though both of them have a 1 on the left of them and above them?
Oh. How can I know that? The amount of whiles and x in this position. Yeah, that was the easy part of the problem, because you always are going to start from this cell, from this one, so from the 0, 0.
Yeah.
That's the condition, one condition. So if you know that, you just need, as I told you before, you just need to move to copy any values that you found of x or y, and at the same time that you are making these zooms that is taken from the left to the right and from the up to down. So that means if you are in this position.
Okay, so you're only adding the one from the opposite direction. Okay, I got you.
Yeah, you're going to compare these two values in the same position. Suppose that we have an x here, so that is going to convert that in 2, because you have one value of x, so that's going just to increase. And yeah, you need to be aware of that. Yeah. So the first thing that I did is just build this the matrix for each character X and Y. And the second part was to get these values, like let me check these values from the left to the right. So that means for X is just 1 1 1, and this is going to be 0 0 and 0 for each row, just from the left to the right. The same goes for Y. This is going to be 1, this is going to be 0 and 0. Ah, this is 1, sorry, because there is 1 1. That's the first part. The second part, sorry, the second part. The third part is now you need to take the value that it's up, like this. 1 and 1, you are just copying from up to down. Yeah, that's just the value. And for this part is just 0 and 1, 1 and 1 is just 2, and 1 and 1 is just 2. Yeah. And while you, in the meanwhile you are doing that, you are going to compare each value in the cells. If they are equal and the value is greater than, or the frequency is greater than 0, and you just increase your number of matrices. So yeah, that was the idea of building this matrix.
Yep. Yeah, you were thinking. I like how you're creating. So this would technically be dynamic programming with the additional matrices mapping the x's and the y's.
Yeah, that's just the small part of the dynamic programming.
Mhm.
Because I just go straight forward for the greedy approach, or the brute force approach. Sorry. And that just give me this verdict, time limit exceeded, because I was trying like to build any like this star with this square, and again start with this another submatrix, start with this one.
Oh yeah,
And
that was what I was talking about, Jim. Yeah.
yeah, you try every possible combinations, and but the risky part of that is just you need to count again the frequencies of x and y's and these possible forms, like this, and whole square. Yeah, and this is just some extra time that I didn't figure out at first, but after that I just come with this solution.
Yeah, and if you're
For
iterating over
months.
that Bruce force, you're covering so much space.
Yeah, it seems simple, but
What was the
it
constraints of this one?
sorry.
The constraints of this problem?
Oh, it was. This is the size of the matrix. It's like 1,000. So I was just with confidence to get with brute force solution, but that was the reason why I was confident in this in my previous approach.
Yeah, it seems smaller
Trying,
for a medium problem.
yeah, probably the the author of this problem probably set some conditions so to um, to avoid these kind of solutions. Yeah.
Mm-hmm. Yeah.
But yeah, it was close. Even it was close. Just 6 Ks before pass. Yeah, that was
Nice.
my
Nice,
fifth
nice.
solution.
I'm gonna be hopping off
Awesome.
in like 10 minutes, but I mean, all y'all can feel free to hang out and continue sharing solutions if we don't make it before then. But did anyone else have another solution to the third problem or a different programming language? All right, then last but not least, the hard problem. Did anyone solve that? I know Omar did. He posted his solution in the chat.
Yeah, Martin also did. He also posted his solution, the GitHub link.
Mm-hmm. Oh, this is the medium one. Yeah.
Did you say we're on problem number 4 already?
I'm just looking at Martin's solution for number 3.
Oh, number 3.
Mm-hmm.
Yeah.
It's just a plain prefix sum problem. So you build a 2 prefix sum for x and y, and you just, if you have a prefix sum, like you can freely compare the number of, the sum of numbers in the given area. By area, I mean any rectangle. But here, it only asks for the number of x's or y's starting for your upper left corner is like 0, 0, so it's very easy. Yeah, so that's all you have to do. So I compare at line number 36, I compare pre1 ij and pre2 ij, and if they're same, and you have to have at least one x. So at line number 37, you have pre1 ij greater than 0. If those two conditions are satisfied, then you increment answer by 1.
Mm-hmm. And the prefix sum is where you just, similar to what Fernando did, that's a prefix sum, same thing?
I actually couldn't see his solution, so I don't know. But like I heard some terminology like DP, but yeah, it could be considered like sort of DP, but like we don't call it DP actually. It's 2D prefix sum. But I think like in essence it should be same, I guess.
Yeah, it's very similar. Cool. And then you said, I don't even know what the hard problem was. I didn't even look at it.
So I use Robin Carp for string comparison. So
I don't even know what the problem is. Let me see.
you're trying to build a given string target from like given words, and for each words you have some codes corresponding to the word, and you want to minimize the codes to build target string. So essentially you have to match strings fast, and one key observation is so for DP you have some transition. So your DP have big of n state, and for each state you have some number of transition, and the key observation is that number of transition cannot be greater than big of square root of n. Can you see why? and that's line number 112 to 117. I'm trying to find all length, like the set of all length of words. So for each word, the word has a length, right? Size of length, size of the word, and there cannot be like not more than square root of n number of length, like unique length. Does that make sense?
No.
So I'm claiming that at line number 17, I'm gonna have some array of length, and that size of that array is not greater than big of square root of n.
Line 17.
Line number 117.
Oh.
117.
Mm-hmm.
So I'm trying to find the unique length of words, and the number of unique length cannot exceed big of square root of n.
So you applied all the constraints there. Is that the same?
I'm sorry, what?
Did you do the constraints check in the problem statement? They were saying like, the value should be 10 to the power 4 kind of length check. Is
Yeah,
it
of course,
length
of course.
check for that?
Yeah,
Okay.
of course I did.
Yeah,
So I'm claiming that.
the
So
code that you would same for that reason.
I'm sorry, what?
No, the unique length that the function returned, right? Is that for that reason?
Yeah. If
constraint.
you look at the,
Okay.
if you look at, you're right. If you look at the constraint, the total sum of words I dot length is less than or equal to 5 times 10 to the 4th. Suppose like, say, suppose you have like words all different in length, okay? So first word has length 1, second word has length 2, third word has length 3, 4, and on and on. If you sum them up, like what is the biggest number, biggest size that you can have such that the sum of length is less than or equal to 5 to the 10 to the 4th, 5 times 10 to the 4th. So I'm saying 1 plus 2 plus 3 plus ... If you add them up until k, what is it? If you sum all natural number from 1 to k, what is it?
Not positive.
Sorry, what?
Not
K
positive.
into k plus 1 by 2, something like that.
That's right. K times k plus 1 divided by 2, and that should be less than or equal to 5 times 10 to the 4th, right? So your
Okay.
k, your largest length cannot be greater than square root of 50,000. Does it make sense?
Yeah. Yeah.
So that's why I'm trying to get, and that will be your number of transitions. And at line number 17, I define length, which is all the unique length of your words. And if you look at line number 136, I'm trying to go over all the unique length, and I'm gonna take the substring of what the target string from certain range. So line number 135 takes big of n, right? And line number 136 takes big of square root of n. Does it make sense?
Nah, I don't know that word that you're using.
Yeah.
What?
I don't know that word that you keep using.
Which one? Square root?
Yeah.
Yeah. So square root of 100 is 10. Do you get that?
Oh, square root, right? Okay.
Oh, okay.
Yeah.
Okay.
Square root.
Square root.
So line number 135, it takes big of n to go over all the I from 1 to n. Does that make sense? that's big of n, right?
Mm-hmm.
And line number 136, that loop goes for big of square root of, well, not actually n, but like big of square root of 50,000,
Mm-hmm.
as I said before.
Yeah.
So it is guaranteed that so the whole loop takes it, it is guaranteed to take less than or equal to big of n square root of n, where n is like say 50,000. Okay,
Mm-hmm.
so it is feasible, and all the other things are inside the loop, the nasty loop, line number 137 to 144, they're all big of 1.
So all this stuff here.
Yeah, and that part is robbing carp, or sometimes it is called rolling hash or polynomial hash, and it is used for fast string comparison or pattern matching, more precisely.
It sounds like you don't like for loops, but you're putting an emphasis on it to make sure that we know that what's inside of these for loops are extremely efficient.
I don't get it. What?
Well, it just sounded like you don't like for loops. It sounded like
No, I didn't. No, I didn't say that. Why would I not like for loops? No, I like for loops,
well,
and they're essential.
okay, gotcha.
Yeah, so I emphasize line number 135, 136 because that's the time complexity.
Mm-hmm.
I'm trying to convince you guys that like the time complexity is okay.
Mm-hmm.
Okay.
And obviously it's a working solution. Your solution to the hard problem always is. And then so this is the time complexity, but you did put an emphasis that these are all O of 1 in here, right?
Oh yeah, line number 137 to 144.
Mm-hmm.
Yeah, the one inside the nasty loop is big of 1, but I can explain it here because it takes a while to explain robbing carp. So you might want to look at it.
How do you spell it?
Robbing carp, Rabin. This is the name of the person whoever invented it. So Robin and carp.
Robin Carp.
Mm-hmm. That's the name of whoever invented the algorithm.
Robin Carp.
So it's mainly
algorithm.
used for pattern matching. It gives unique hash value for any substring, and that's what I'm trying to do. So if you take like substring and compare it naively, it will take big of n. But if you pre-process with polynomial hash, what's called polynomial hash, then you can find the unique hash for substring in big of 1, and the probability of collision is like 10 to the 9th, which is pretty high actually. I wanted to use 2 robbing carp. If you use double robbing carp, the probability of hash collision is 10 to the 18th. But then I cannot use unordered map for pair of integers, so I use single hash, and I think the problem is lame. I didn't like the problem. The problem setting is very, very bad.
The problem setting? What do you mean?
We call it, like writing a problem, we call it a setting a problem in CP community. Writing a problem is like, we call it setting a problem, and we say problem setting is bad if the problem is bad. And in my opinion, the problem is bad because it forces you to use a single robbing carp. If you use double robbing carp, it will blow up, or you'll get a TLE. So as you see, like at line number 128, I said I have like RK1, which means like robbing carp 1. I originally have 2 robbing carp RK2 with different P's and M's. So like you have to like mix up some prime numbers for robbing carp. So if you look at line number 19 and 120, 119 and 120, I have like 2 P's and 2 M's. Therefore, prime numbers for robbing carp. And if you use more P's and M's, like the probability of your hash collision gets diminished a lot. But if you use single Robin carb, like the probability of collision is pretty high, like it's like 1 in 10 to the 9th. So yeah, I mean overall I didn't like the problem.
Can I ask, how does the fact that you're not able to add 2 Robin carps but you're only able to add 1 Robin carp make the problem set bad?
Because like usually I have to use 2. Using 1 is very dangerous.
Just to prevent the collisions?
Yeah, of course.
So the problem forces you into a position where the chance of collisions is increased, and that's what makes the problem set bad?
Yeah, that's what I believe. There of course there are other solutions, but I don't know. This problem like forces me to use only single Robin carb, and I was very annoyed by that. Usually, if the problem setter intended the problem to be solved by a Robin carb, your time limit should be set such that like people can use 2 Robin carbs.
Yeah, that's an interesting solution. I half understood the problem to begin with, but you explained things really well, man.
Oh yeah, I wish I understood half of it. Seriously.
I think the big thing is just that I have to really focus hard to hear what you're saying, because I just don't use the lingo that you use on a regular basis. So I kind of have to think about, sometimes there's certain words that I have to think about more. And then the accent a little bit. I didn't even know you were saying square root. So I was like, what the hell is that? And then you said square. You did the example of 110. And I was like, oh, square root. Okay, cool. But
wait, how do I say square root? Is that
square root?
A bad accent?
Square root? Well, you were just saying it fast. It sounded like one word, not 2 words. And I was like, well, what the hell is he saying? Nah, but you're good, man. That's awesome. Thanks for sharing. Okay. I'm going to look more into this algorithm, too. It's interesting. It seems like there's so much just built up before even the Robin carp algorithm comes. Like, there's so much more involved in a solution like this, you know?
Oh yeah, so I didn't talk about the DP part. So the DP relation is line number 143. Can you guys see that? Line number 143.
Yeah.
So DPI can be, there could be many candidates. So length, so LEN length from line number 136. Length is the substring that you might have match between index I minus 1 and I minus length. Okay. So there are square roots n number of transitions, and that is signified by line number 136. And so for each I minus len, previously it has been, so DPI is the minimum cost that you have to spend to match until index I, starting from 1 to n, okay? Starting from 1 to I. And DPI minus len is the previous DP value at index I minus length. So from index I minus length to I minus 1, you have that the substring that has matched, and the minimum value that matches the cost is MP key. So I have previously defined my MP. So MP is, where is it? MP is at line number 123. So that's an unordered map that maps hash value to the minimum cost that has that hash value. So if you look at line number 129 and 130, I define MP hash I is CI, or if there is a existing value, I'm gonna take the minimum of the new value. So MP key is the additional cost, and I take all the minimum value over all the transitions of len. So yeah, basically it's a simple DP, but the transition part requires pattern matching of strings, so that part was kind of tricky. And I think in this problem, the most tricky part is line number 17. That you have to understand the number of transition is at most big of square root of n.
17.
So, 117. 117 kind of guarantees that your number of transition for each DP state, does not exceed square root of n, or square root of 50,000. So as long as you can do that, like the DP recurrence relation, or it's a DP equation, is not that difficult as long as you can come up with two observations that that you have to do the fast pattern matching, and that the number of transition does not exceed of square root of n. Okay.
Okay.
By the way, I shared the link for this Robin Karp algorithm. So the chat.
Oh, just
You can take a look at that.
you can just Google go to Google and Google for CP-algo polynomial hash, then you will get it. I think it's the best reference for any CP algorithm. Let me type it here. CP-algo, and go for like polynomial hash, or rolling hash, really. Hash.
So there are a lot of string pattern search algorithms are there, right? One is this. I'm looking at the Geeks of Geeks list. They had listed almost 10 kind of similar algorithm for the same problem. So it's kind of interesting. I think you can try different algorithms to see how
Wait,
it works.
who is Todd? Todd? Is this a working solution? Use a stack?
Oh, sorry. No, it's not a working solution. I just thought I'd share it.
Oh, okay. I was kind of shocked. I never thought of stack.
I mean, it works. It just times out. I think I got like a timeout error. So it worked for, I think, half the problems, and then the input got too large.
Yeah. We call it actually not working because anyway.
Yeah.
I like this website, CP algorithms. It's kind of interesting. Yeah. A lot of
Yeah, it's the
reading has to be
best
done.
reference I know.
Yeah, algorithms for competitive programming. How many different algorithms do you think you know offhand, Martin?
Very few.
Really? So how'd you know about this one? Is it like documentation where you kind of read the documentation as you're coding to build stuff? Are you using documentation during the competitions?
Oh yeah, we in CP community we call it a template. So I have like a lot of templates, almost like 2,000 lines.
2,000 lines of code?
Ooh.
Yeah, but that's only like part of all the CP algorithm.
So you
I
just
only
copy
know, like,
you just copy and paste and make the minor modifications that you have to make for a working solution?
I don't even copy and paste. I just have it. I just, yeah. Actually, when I submit like at places like Code Forces or at Quarter, I just copy and paste the whole 2,000 lines and submit it. So, yeah.
So by
But,
the
like,
way,
that's only like a very few part of like whole CP algorithm. Like I'm only a beginner. Like in CP community, I'm only a beginner. So there are a lot of algorithms that I don't even like. I haven't even heard of. And that's like I should estimate somewhere around like 70 to 80% I never heard of, and I only like 20 to 30% of all the CP algo. So yeah, I'm only a beginner, like, to be honest, in CP community. Like, yeah, it's just too intense.
do you actually use these algorithms to work or just an interest hobby?
I'm sorry, what?
You do you use these algorithms in your work or just an hobby?
Of course not. Who uses dynamic programming at work? That's not. I mean, I heard that questions like a lot of times, like already like several times, but no, of course not. I mean, yeah, I mean, and everything is like all packaged, you know, like you don't have to, you know, write your own hash algorithm. Like everything is out there, and you can use it out of the box. So
Yeah.
no, don't bother. Just use the library.
True. Cool.
Okay, that's it for me.
All right, it's already 1:15. I'm gonna hop off anyways, but I don't know if anyone else has any other hard solutions that they want to share, or even one of the other easy mediums. Feel free to continue sharing. I gotta get up early, so I'm hopping off. But thank you everyone for coming, and hit me up anytime.
All right. See you guys. Good night.
Thank you.
Good night,
Bye.
everyone.
Listen, bye.